Hello friends, today's question. At time t equals 0, terminal A in the circuit shown in the figure is connected to B by a key and an alternating current IT equal to I naught cos of omega t with I naught 1 ampere and omega 500 radian per second starts flowing in it with the initial direction as shown in the figure. At t is equal to 7 pi upon 6 omega, the key is switched from B to D. Now onwards, only A and D are connected. A total charge Q flows from the battery to charge the capacitor fully. If C is 20 microfarad, R is 10 ohm, and the battery is idle with the EMF of 50 volt, identify the correct statement. So these are the four options or statements which we are going to check which of them are true. And this question was asked in the advanced paper of 2014. So we have a figure, and initially capacitor C is connected to the main supply with the help of this point B, and at time t is equal to 7 pi by 6 omega, the key is switched from B to D. So we have to check which of these options are currently, you can say A is correct one. In this case, we are going to first of all draw a, you can say, the graph for what will be the current through the capacitor and voltage through the capacitor when A is connected with B. Okay. So it is given that I of t is equal to I naught cos omega t, where I naught is 1 ampere. And so this is when A is connected with B. So under this condition, we are going to find out what will be the capacitor current and what will be the shape of the voltage, capacitor voltage. So you can just draw it. So for value of omega t will be equal to 0. So the capacitor current is going to start from the peak value. So it will be going something like this. And this will be our pi. This point will be 2 pi. So this will be our pi by 2. And this we can see is our IC, capacitor current. And similarly, we can draw the capacitor voltage. And this is our capacitor voltage. And we are going to check the option A. In the option A, it is said that the magnitude of maximum charge on the capacitor before t 7 pi by 6 omega is 1 into 10 to the power minus 3 coulombs. So we are given IT is equal to I naught cos omega t, and we are supposed to find out the charge. So we know the relationship between the current and the charge. So current is equal to dq upon dt. From here we can say our dq is equal to I times dt. we substitute value of I, we can write that dq is equal to I naught cos omega t times dt. Value of I naught is 1. We substitute it, we get our dq is equal to cos of omega t times dt. So from here we can say if the total charge is represented as q, then the q will be the integration of dq. We substitute dq and this will be coming as cos of omega t and times dt. Now we have to find out what were the limits of this particular integral. So first of all, obviously it is going to start from 0. Okay. So we can write the lower limit will be equal to 0, and now we have to define what will be the upper limit. Okay. And in the question it is said that the charge in the capacitor before t is 7 pi by 6 omega, and this 7 pi by 6 omega will be approximately, it will be lying somewhere here. We can just approximate it. So this will be our t is equal to 7 pi upon 6 omega. So it means we are going to find out the upper limit which will line along this portion. But it is said in the question that the magnitude of maximum charge. Okay. So we have to keep in mind that the charge should be maximum. Charge should be maximum. Okay. So in this case, if we see the graph for the current IC, after pi by 2, the current start to reverse its direction. Okay. So it means from this maximum value, or we can say from 0 to pi by 2, there is a continuous, you can say the current is positive, and therefore after pi by 2, the current is going to, current changes its direction. Okay. So let me write it here that current reverses its direction at t is equal to pi by 2, and because of this the capacitor starts to discharge. So it means that the capacitor starts to discharge. So it means the capacitor will hold maximum charge at t is equal to pi by 2. So we can say the upper limit of this integral will be our pi by 2. Therefore we can say that our q will be equal to 1 upon omega sine of omega t, and this comes our 0 to pi by 2, and this will be equal to 1 upon omega, which comes upon 1 upon 500, and this will be our 2 into 10 to the power minus 3 coulombs. So this q is our maximum charge, and the value of maximum charge is 2 into 10 to the power minus 3 coulombs. And the option that is given to us, it states that it 1 into 10 to the power minus 3 coulomb So option number A is incorrect. And from here also we can make a conclusion that option D is correct. So from here we can say that option A is incorrect and option D is correct. Now we come for the option B, and for option B it states that the current in the left part of the circuit just before t is equal to 7 pi by 6 omega is clockwise. So this is our left part of the circuit and this is the right part of the circuit. So it says that the current in the left part of circuit, it means A is still connected with B and just before t is equal to 7 pi by 6 omega. So we already defined a point 7 pi by 6 omega, and it says that the current will be in clockwise direction. Okay. But from the figure we can clearly see that the current initially starts to flow up till pi by 2 in the positive direction. So it means initially the current is flowing in this direction, but at pi by 2 the current reverses the direction, so it becomes now counterclockwise. So we can just once again draw this approximate figure, and we have this, we are only interested in current. So this is our pi by 2, this is pi, and we were having 7 pi by 2 somewhere here approximately, and from this we can see that t, which is close to 7 pi by, sorry, it's not 7 pi by 2 but 7 pi divided by 6 omega. So for option B we can say that current goes in clockwise direction up till pi by 2. After that current reverses its direction, that is counterclockwise. And we can also prove it mathematically also. So we already know that the charge will be equal to our I naught omega, and we have this is sine of omega t, and we can find out at t is equal to 7 pi by omega, you can see q at 7 pi by 6 omega, this will be coming as -1 into 10 to the power -3 coulombs. So this negative sign indicates that the direction of current will be reverse. Negative sign indicates that direction of current is reversed, that is counterclockwise. Therefore, option number B is incorrect. B is incorrect. And so option number B is incorrect. And now we are going to find out option C. Immediately after A is connected to D, the current in R is 10 ampere. So we come to option C. And in option C, now the point A is connected with D. Yeah, A is connected with D. And we have a capacitor here, even a resistance, and a capacitor here. And the capacitance is given, sorry, this is not capacitance, but a supply voltage of 50 volt and resistance of 10 ohm, and this is a capacitance. Now we can find out what will be the capacitance voltage, that is our VC. So we can say that our VC will be equal to Q upon C. Q we just found out is 1 into 10 to the power minus 3 divided by 20 into 10 to the power minus 6. So this gives us that our capacitor voltage is our minus 50 volt. So which basically means that this top one will be negative and bottom one will be positive. So we can replace it by a equivalent voltage source like this, and this voltage source is of 50 volt and it is connected to point D with another voltage source which is also a 50 voltage source and a resistance of 10 ohm. So from here you can see that these two voltage sources are in series addition. Okay. So you can say that both voltage sources are in series addition. Therefore, total voltage will be equal to 100 volts, and therefore you can say that the current I will be equal to, let us call this as VT divided by R, and VT is our 100 divided by 10, and this comes as 10 amperes. So the current, option number C, is our correct option. So you can say option C is correct. So this was the question which was asked in the advanced paper of 2014. So this completes the question. Thank you.